So thank you for having me. And we're x.ai. What do we do? Well, we use AI to do something, and that's really actually one thing, and that's what we call magically scheduled meetings. So we're building a personal assistant. How does it actually work, you might ask? So a very typical use case is that after this meetup, you send me an email and say, Alex, let's meet up for coffee next week. Now, the typical conversation we have over email is that on the pain side, we'll have that email back and forth and say, hey, I'm free next week, Tuesday, 2 p.m. or 3 p.m. We can do coffee, maybe like the Great Coffee downtown. You may email back and say, yeah, actually, I'm out of town next week. How about the week after? Oh, by the way, I actually don't want to go downtown. Can you come to Union Square? And we have that back and forth and over again, average 8 emails to 10 emails to schedule one coffee chat. And you do 10 of those. It's kind of painful. So if I had an assistant, the interaction would be somewhat similar, except that Jane would send an email to Alex, and Alex would say, yeah, sure, we'll meet for coffee. Just coordinate with my assistant, Amy. And Amy will now then have those conversations with you over email, being able to understanding my calendar, understanding my preferences, and really negotiate and coordinate on my behalf on how, when, where should we have that coffee chat. So that's what we're building at x.ai. Now, we do a lot of machine learning, natural language processing as well, but I'll leave that presentation to my co-founders on the data science side. And today's talk will mostly focus on the engineering side, particularly on how do we build Amy with Scala and JavaScript, and talk a little bit about the tooling that we use. So, building AI is hard. We try very hard to not reinvent the wheel. And here's a bunch of logos. Everything's built on AWS. Mongo is our primary database, and we do have both JavaScript and Scala in our production system, and we leverage some of the associated frameworks like Spark and Angular, Node on both sides to help us not worry so much about things that are already been solved, but focus more on the AI side and the customer experience side. And we talked, actually the earlier talks talk a little bit more about tooling and what platform. So one thing I do want to make sure you know, if you take out one fact from this talk, is that do not ever ask us what mobile device we're on, because we are on all devices since we are on email. So any platform that can receive and send emails, we work with that. So, Scala and JavaScript. When we first started the company, we thought very hard on picking the right tools. So we started off on the back end thinking of, okay, it's going to be machine learning heavy, it's going to be NLP heavy. What are some of the viable language that we can leverage? And personally, I'm more of a Python guy to start, so certainly Python was one of the top choices, and then our other choices really is Java, who have both Python and Java have a strong community in NLP and machine learning. We decided to go with the JVM-based language because we like the Stanford NLP library and then other libraries that we have seen so far, but we didn't run like Java. So after thinking more, we certainly have some of our friends and ourselves really like Scala, particularly for its type system, that it minimizes or removes side effects, being able to not have data mutable, and all those things that we really enjoy and actually fits really well with our use cases. So we ended up on Scala. Now, you could argue to build a full system on Scala, but again, trying to pick the right tool for the right problem. We do have a few things that we need that are better suited for more of a web software, web language, and to us that's JavaScript. In terms of what we're not building an AI in a black box. We do talk to the world. We receive emails. We talk to different APIs. We connect to your calendars. We want to know all the different things that you can tell us about you to help you maximize the personalization of the service. So that is just looking across simply, there's more bindings and APIs available for JavaScript. We also want to stand up a bunch of internal web apps that are actually pretty complex. And particularly our CTO is a big fan of JavaScript and he's strong at it. So being able to use Node and Angular, it allows us to build a much faster sort of internal front end to be able to look into our data, be able to run an annotation campaign and so on and so forth. So kind of that's how to divide. If there are strong data science, a lot of data processing, it falls in the Scala camp. A lot of kind of dealing with the rest of the world, having to build some sort of web app, we went with JavaScript. So one of the main problem or complexity come with having multiple languages in your system is that database access. We have two production level systems that they work with similar, if not the same types of objects. They all have represented their object very differently. Particularly in Scala, we have very strong type system that it sort of reflects the schema, but then in JavaScript we don't really. Now we are using Mongo as our database, which again in a different presentation I tell you all the great things about Mongo and all the bad things about Mongo, but it's, for our applications it has been great. But one of the things about Mongo is that it's schemaless, which is again is awesome for a startup who's iterating your schema all the time in the beginning. But to be able to sync the schema across the two languages is a challenge. You want to make sure to minimize those pain of one side of one group of engineers change their schema and then all of a sudden on your other side start breaking everything that you thought your service-oriented architecture is not very good. So what we have done is we found a great library called Mongoose, which is a object modeling and querying library that allow us to express the schema on top of Node.js, which then, so pretty much all our schema are held in Node. So then we built an internal API with Mongoose so that pretty much all database access in production goes through internal API. There are some queries that we're still tunneling through. We're going to fix that soon. But primarily all the data have to access the internal API to get through Mongo, so that we have that schema control. So by having that, we both get the advantage of being able to iterate the schema very quickly in Mongo, but also having some control over like what are we putting into the database and knowing what's there. And they also allow us to coordinate across. Another main thing about what we do is that when you have all these different services, what are some of the ways you can communicate across them? So I think James talked a little bit more about SQS, and that's certainly a big piece of our architecture. That for example, this is on the left side is a sort of typical queue-based architecture that we have on some of the key components. Email comes in, we have a set of web apps that really just consume the email. Pre-process them, and then we can dump it into a distributed queue on SQS on AWS. That way, it then gets consumed by a set of annotators, which is our machine learning extracting entities from the text, and then it gets dumped into a separate queue, and then it gets consumed by classify, which is another set of machine learning components that we have. And it goes on, and our whole system is layer by queue, so that it enables us to much easier to connect different components. If certain components go down for a short period of time, that's actually okay. That's actually an added benefit of working with a system like emails, where I originally came from my prior startup. We're in the real-time analytics space, where real-time does mean pretty close to real-time. But for here, having a 30-second delay because certain things goes down, or like there's some sort of backup, is actually not a big deal, because we are working with this asynchronous system of emails that when you send someone an email, you don't expect an immediate response back to you. Actually, as part of user experience, sometimes it's actually better to have a delay to come back to you. So a quick use case on how someone would use our service is that someone will say, sure, let's meet up, and then 45 seconds later, send another email coming in and say, for that meeting, make sure you push it to like September. So actually having that delay give us additional functionality of sort of receiving instruction from the users about like how would you want to instruct your personal assistant to take on this meeting, and what are the priorities, and so on and so forth. And then we're not at a service-oriented architecture, trying to balance between on shipping product versus how to get things that are working but clean enough for our case from where we are. We really just have a set of RESTful API across, and that's where the internal API is implemented on. Let's just make it a little bit easy to talk through. We do run into more challenges particularly on the JSON serialization and deserialization side. Just we have quite complex models, and sometimes we run into things like I think the Scala case classes, you can have like 23 fields, and we went above and beyond that. We actually have to like patch it and to make sure that we can handle the serialization and stuff like that for a pretty complex model. So back to the earlier slides on where do we make decision on what logic goes where. There are times that as we grew the product and build out the feature, certain things we end up pretty much more features end up migrating to Scala because the complexity start to grow. So for example, some of the business logic about how we would respond back to you based on the different scenario, different environment, or a certain event had happened. Earlier, we were able to kind of build it with JavaScript, but then as things become more complex, it is much more error-prone for us to continue some of these logic in JavaScript. It's much easier to actually pull that out and put it in Scala for us. For example, another example would be what we call surrender meeting. So for good customer experience, that when you ask us to schedule a meeting for you and your friend, we will ping your friend, and if your friend ignores us, we'll nicely nudge that person again, and then as the time gets a little bit closer, we'll nudge that person again, but then we stop. If your friend really just would not want to talk to us, we actually come back to you and say, hey, listen, I guess your friend doesn't like you as much as you think you do. So that's how we surrender. But that is the absolute base case. There's actually another 20 cases as you really think deeper about it, based on what state is the meeting. Did the person ever talk to us, or was that person responding they said no to a time, but then they actually respond back to say something and then they stop. So based on the communication flow, we actually have different logic in handling how we think about our surrendering. We really want to balance this idea of we want to be a really good personal assistant to you, that we want to be nice and persistent, but at the same time we don't want to be annoying, right? So a lot of our customer experience is built into these interactions. It's pretty quickly become very complex business logic as we want to build out the feature and want to add more sort of better experience to you. And then another idea would be when we have before things that are pure rule-based and then want to add on machine learning to that service, then we want to actually move over to Scala. One thing we do is generating meeting titles. So at first it's much easier to take some sort of a n-gram approach to say, hey, if we, based on this scenario, we will generate this particular title because we grab certain title from certain text from your from the context of the email. But as you want to really summarize the email to put it in a few words in the title, pretty quickly you want to start applying machine learning and more complex NLP to the problem. And at the end of the day, it's just really not feasible to do any meaningful machine learning in JavaScript, at least for us. So yeah, we definitely see a trend as we move forward, more and more features get implemented in Scala, particularly some of the heavier business logic or machine learning type systems. That's what we do. Happy to take any questions. Yeah.
So, thank you. Very interesting presentation. I actually just made a meeting yesterday for tomorrow with Amy Ingram.
Okay.
through Amy Ingram.
Yeah.
Is Ingram a common name for Amy?
Well, it's so it is a play on AI. Yeah, it's a play on AI, but also Ingram answer n-gram, which is another AI techniques, basic AI technique that we use. So yeah, there's a few little nerd plays in it.
I have a real question.
Yeah.
More substantial question. So I build NLP products too. And of course OpenNLP is a great library and I use Java for that reason. But not just for OpenNLP, but things like Ulima and Gate, which allow you to basically take the information that you get through one NLP process and pass it on to the next thing in the pipeline. You mentioned annotators, and that's exactly why Ulima was invented by IBM, precisely to be able to pass this information through different modules. So I'm wondering why you guys decided to go to Scala. Does Scala have anything like IBM's Ulima or Gate libraries?
So I think pipelining is a pretty common pattern. For annotators, you do a bunch of pre-processing if you want to take out stop words or not. If we actually don't like.
I mean, okay, where for instance, so IBM Watson, they do various processes, right? And they have many different processes for extracting information, and then they pass that information from one process to another. So I'm not under this low-level pipeline, like tokenizer, artist pitch tagger, and so on. But extracting information about time, extracting information about places, extracting information about relations, preferences, and so on. And the information you get from one process, say something that extracts time, is then sent to some other process which may extract relations or locations and so on. So it's a very easy, convenient way of passing these annotators from one process to another. And I'm just wondering why you chose Scala. Does Scala have anything like this?
Oh, sure. So for example, Spark that we use allows you can do some sort of pipelining, into passing that information, or you can do. I mean, we also do, using the database as an interim where you save pre-process or subset of data or enriched data into the database where you can have multiple layers. You just keep the raw and then you keep adding on or transforming or augmenting your data. And then you just save it back into the database in that sense. You don't have to, I think there's many ways to pick and choose what features to save and pick up. And we also internally have sort of like a feature database where you don't have to necessarily look at the raw. You can just actually go off of the set of features that are the different modules have created those features so that you can directly pick and choose the features to implement your particular piece of code to make life easier. So yeah, I think you can implement that in many ways, and Scala for us as a language we like it better, but not necessarily for.
I'm strongly advising you to look at Ulima.
Okay.
IBM has developed a whole big architecture just for many processes to combine information, NLP information. This way.
I'll check it out. Go ahead.
On one of your previous slides, you kind of had a Venn diagram of functional programming. Was kind of
Yeah, I totally forgot to talk about that. So yes, one of the actually main reason too is why I like Scala a lot is functional programming. I think it really built for it. Again, it's in the middle because you can write functional programming in JavaScript too, and we do certainly strive for that. But Scala on the Scala side definitely is easier or more complete in the sense to write functional programming there, and it certainly to me it makes me super happy, and I think my team are super happy in writing Scala and functional programming.
But yeah, my question is just around what's so functional about your problem that you went with the pure functional?
So it's almost problem agnostic that I think you just write better code for functional programming because of, again, some of those things I mentioned in terms of having a strong type system that, minimizing side effects. So like when you compile your code, you actually have a much higher confidence. At least I had a lot more confidence in my code running than my Python code that I used to just code up and run. So I think combining those different pieces allows you to write better software. But it's not necessarily to the machine learning or NLP at hand. I think you just generally write better software. Personal opinion. Yeah. Go ahead.
So I got a question about software. How do you handle errors in the email itself? I'll give you an example. Hey, let's meet today, Sunday, June 22nd.
Yeah.
Not Monday. How do you handle that error?
So I think that's the fun thing about dealing with humans, that they make a lot of errors, and sometimes they think the machine makes the error. So yeah, that's one good example. Or like you're trying to schedule a meeting when you're traveling, and maybe not even an error. Like we just like you happen to be traveling, and we didn't know the fact that you're traveling. So that we thought that you were in town, so therefore like you cannot possibly be having a face-to-face meeting in San Francisco if you're here. But I think a lot of it, just overall thinking about how do we think about the problem is that first of all, our general philosophy is because we don't have a web app or an iOS app, all of our interfaces is in this conversation, right? Like we email, it is in the email that we sent to you, like that is the interface, like this idea of invisible software, right? So a lot of these items, including sort of error correction, instead of having a form that tells you that you input something incorrectly, we will have to kind of respond back to you and say, I think you said this. I'm interpreting it as you have said this, but you should let me know if we didn't get it right. So we just generally take the approach of when there's in the eye of uncertainty, we over-communicate. But again, it is a balance back to because if your assistant constantly asks you questions, that's not a very good assistant, right? So it is a big user experience challenge of like, when do you over-communicate? When do you know that you make good guesses? And part of it is that how good our data science team is in making those guesses.
Thank you very much.
Thank you.